Hi children, we shall see about refraction of light through a glass slab in this session. So in this picture, you can see a glass slab and a beam of light. So when you observe closely, the beam of light, this is the incident ray, and once it enters into the glass slab, you can find a small bend inside the glass slab and it emerges outside. So in this session, we shall see why this happens. So before stepping into the topic, you already know about refraction of light. So refraction is what? The refraction of light takes place when light travels from one medium to the other. So here the two mediums which are considered are air and glass. The second one is why there is a slight bend in the glass slab. So the speed of light in the mediums are different. That means the speed with which light travels in air is different and the speed with which light travels in the glass slab is different, and this depends upon the density of the medium. So because of this change in speeds, it occurs due to the change in the speed of light on going from one medium to the other. Okay, so now to the experiment. This is a very simple rough diagram of a glass slab. This PQRS is considered the glass slab, and this one is the air, that is the first medium, and glass, and again air medium. So now if you observe, this line is your incident ray. The incident ray, and once it enters into the glass slab, it undergoes a slight bend and then it emerges outside. So now we shall see in detail about the experiment.
Refraction of light to a rectangular glass slab. Let us explain the refraction phenomenon by a glass rectangular slab. Fix a sheet of white paper on a drawing board using drawing pins. Place a rectangular glass slab over the sheet in the middle. Draw the outline of the slab with the pencil. Let us name the outline as ABCD. Take 4 identical pins. Fix 2 pins, say E and F, vertically such that the line joining the pins is inclined to the edge AB. Look for the images of the pins E and F through the opposite edge. Fix 2 other pins, say G and H, such that these pins and the images of E and F lie on a straight line. Remove the pins and the slab. Join the position of tip of the pins E and F and produce the line up to AB. Let EF meet AB at O. Similarly, join the positions of tip of the pins G and H and produce it up to the edge CD. Let HG meet CD at O. Join O and O. Also produce EF up to P as shown by a dotted line. From this activity, when a ray of light passes through a rectangular glass slab, it gets bent twice at the air-glass interface and at the glass-air interface. The emergent ray is parallel to the incident ray and is displaced through a distance.
In the experiment, we would have come across two terms like optically rarer and optically denser medium. If it is a rarer medium, that means that the particles are very loosely packed. If that is the case, then the speed of light can travel very easily in such a medium. So a transparent substance in which the speed of the light is more is called as optically rarer medium. The exact opposite is called as the optically denser medium. As it is a very dense medium, the particles are very closely packed, so that makes the speed of light to travel a little less. So such a medium is called as optically denser medium. So in our experiment, glass is optically denser medium than air and also water. So in this experiment, we derive 3 conclusions. One is about the lateral shift, and the second one is what will happen when light falls perpendicularly on the glass slab, and third one is why is the emerging light parallel to the incident ray. So we shall address all these questions individually. So now there is this lateral shift or lateral displacement. Displacement, as you know, it is the distance. So imagine this is the incident ray. Okay, this is the incident ray. and this is the refracted ray, and this is the emergent ray. Now imagine there is no glass slab at all. So now what will happen if there is this incident ray? If there is no glass slab, that will actually, as per the rectilinear propagation of light, will pass as a straight line. So that is what has been extrapolated, and it is shown as dotted lines here. And since it is a refraction, since now place a glass slab, and you can notice that the incident ray will undergo a refraction. So this incident ray undergoes a slight refraction, so that is, it bends towards the normal, and again at the second interface it bends away from the normal, and now it comes out as the emergent ray. So this lateral shift or lateral displacement is the distance between the actual incident ray and the emergent ray. This perpendicular distance between the incident ray and the emergent ray is called as lateral displacement or lateral shift. So the perpendicular distance between the incident ray and the emergent ray is defined as a lateral shift. So this shift, this distance depends upon the angle of incidence, the angle of refraction, and the thickness of the medium. Now the second question is, what happens when this light ray is applied perpendicularly on a glass slab? So in the previous experiments we saw that the incident ray is actually given at an angle, as an oblique angle towards the glass slab. So instead of that, if you are giving the incident ray as a perpendicular ray at the normal, so what will happen then? So when light falls perpendicularly or normally on the surface of the glass slab, it goes straight. That is, there is no bending of the light ray on entering the glass slab or coming out of it. So in this case, the angle of incidence and the angle of refraction, everything will become 0. So when we are giving the light ray perpendicularly to the glass slab, it just doesn't undergo any refraction, it just directly passes and emerges outside as such, and that is the reason the angle of incidence and angle of refraction both becomes 0. Then the final question is, why is the emerging light parallel to the incident ray? So if you have noticed in the lateral shift, these two lines are parallel to each other. So why does this happen? The answer is very simple. The extent of bending of the ray at the opposite parallel faces of the rectangular glass slab is equal and opposite. So if you notice, or in other simple terms, we can say that since it is a glass slab, it is a rectangular glass slab, this side AB, it is parallel to the side C and D. Since both these sides are parallel to each other, the light rays are parallel. So the simple explanation of this is, the sides of the glass slab AB and CD are parallel to each other, and hence the light ray becomes parallel to the emergent ray.